Okay, then let's move on to the last question of this quiz. Suppose this is the coordinate axis and this is one vector whose magnitude is 4, this is one vector whose magnitude is 2, and this is 30-degree angle. So I want you to get the resultant vector in the component form, in the form of I cap and j cap. So something I cap plus something j cap. In that form, give me the resultant vector. So try this one out on your own. These are very basic questions, but it will actually help you to get on with it. And when a time comes to really solve the complicated ones, you can glide through those problems very easily. Don't underestimate the potential what these problems can teach you. So take a paper and pen and solve this one out, please. Okay, hoping that you've already got your answer. What we have to do is, if you want it in the component form, just keep all the vectors in the component form. Let me call this as A vector and this is as B vector. Now A vector in component form should be very easy for you now to write. A vector would be 4 cos 30-degree I cap plus 4 sin 30-degree j cap. Now this is 2 root 3 I cap plus 2 j cap, and B vector is all along x-axis, so it is actually just 2 I cap. So A vector plus B vector A vector plus B vector is equal to 2 root 3 plus 2 I cap plus 2 j cap. So simple and easy. Now find the magnitude of the resultant vector. Find the mod of A vector plus B vector. Try and do it orally. If you have done it already, you will get the answer as 2 root over 5 plus 2 root 3. Okay. Okay, fine. So these were the basic problems based upon the addition of the vectors and the resolution of vector into x and y components. So we understand the basic of vectors now. What I did was, I did not teach you everything on the addition of the vectors. I reserved it for later for the sake of simplicity. And I also did not teach you everything on the resolution of vector for the simplicity. So what I have done, I have taught you a little bit of addition of vector and a little bit of resolution of vector. And we now understand both of them quite well. So what I'll do now is, I'll revisit the addition of vector, and then I'll revisit the resolution of vector, and then finally we'll conclude this section of vector, and then we'll proceed ahead. But for now, it's a simple thing, isn't it? What we studied before was called as triangular law of addition of vector. What we are going to study now is called as parallelogram law of addition of vectors. What we studied before was something like this. If we have two vectors, suppose like this, the step number 1 in the addition of the vector was to arrange the vectors head to tail. One of the head should coincide with the tail of the other vector. So if we shift this vector parallel to itself, we got this vector. Now the head and tail are coinciding, and in the second step we just join the tail of first vector to the head of the second vector, and the vector should be in a straight line. Okay, so this is what we did in the triangular law of addition of vector. Now there could be an alternative viewpoint to this whole thing. Now instead of shifting the vector to coincide the head with the tail, what we can do is we can bring the vector tail to tail as it was already shown. And then what we can do is we can construct a parallelogram using these two sides. Parallelogram is a four-sided figure whose opposite sides are parallel to each other. That is a parallelogram. So for constructing a parallelogram from two given lines, what we have to do is we have to draw parallel lines. And this becomes the vertex. So this becomes the parallelogram. So all we have to do is from the head of one of the vector, draw a line, draw a vector parallel to the other vector. So the same thing, we can do it here. If we do that, and this we have already drawn, so this becomes a parallelogram, and the resultant vector would be one of the diagonal of the parallelogram with the tail common to the tail of the other two vectors. It's basically the same thing. Either you shift it, make a triangle, or you don't shift it, make a parallelogram, and then join the diagonal. It's exactly the same thing. It's just two ways of looking at the same thing. When we have two vectors like this, now one thing we can do is we can shift it so that the head coincides with the tail like this and make a triangle, and this is the resultant vector. Or we do not shift it, we keep the tail to tail as it is, and we construct a parallelogram, right? And one of the diagonal of that parallelogram will be the resultant vector, like this. It's exactly the same thing. If you would have shifted it to coincide the tail with the head and then drawn the third side of the triangle, it would have been exactly the same. So it's basically the same. It's like looking at it from a different viewpoint. Otherwise, the whole analysis would be the same. So this is the law, parallelogram law of addition. Well, it's very similar. It's the same as the triangular law of addition, but looking at it from a different perspective. The mathematical thing of it will remain exactly the same. As we found out the magnitude of the resultant vector and the angle which resultant vector makes with one of the vector, the same mathematical analysis will go with this as well. So what we did there, we drew a right angle triangle like this, fine, and then we did this is theta, and we found this phi. Using Pythagoras theorem, we found this side of the right angle triangle, and we got the answer as r is equal to root over a squared plus 2ab cos theta plus b squared. Now it's the same thing, we can repeat it all over again and get the same answer. The mathematics is not going to change from the perspective, it's going to remain the same. So everything is the mathematical formula that we studied in the triangular law of addition is going to hold here as well. So nothing is going to change from the mathematical point of view. But it's a good idea to stop at this point, and looking at it from a parallelogram point of view, you find the magnitude of the resultant vector and the angle phi which the resultant vector makes with one of this vector. So you do it, you do the derivation once again, and I'll tell you, it's an early stage for you being in early phase of class 11th. I'll tell you one thing, you don't memorize anything ever in any of the subject. You understand it, otherwise the thing is, one, you will not be able to remember things.